Good morning, everyone. Good morning. Hope all are good. Okay. So we can start our today's class without wasting time. So, remembering what we studied yesterday or last class. Do you remember what we are studying? Yes, right. We are discussing about equations of motion. First chapter. No, second chapter. Right. Then we have discussed different methods to obtain the equations of motion. What are the equations of motion? V is equal to u plus at. V is equal to u plus at. Then second equation S is equal to ut plus half at square. Third equation v square is equal to u square plus 2as. This first two equation is known as vector equation. The third one will be a scalar equation. How it came, that we discussed already, or you can check the previous videos. Okay, so today what we are going to discuss, what is our aim today? We studied this equation, right? Then I want to know where I can use this equation. What is the application of this equation, right? So before starting that, I am asking a question to you. We cannot use this equation all time. We can use these equations where there is a condition. Are you remembering what is that condition? Yes, that condition was? Yes, right, good. Constant acceleration. Whenever this acceleration A remains constant, then only you can use this equation, right? So our application begins here. So you have to think where the acceleration remains constant. That will be our application for these equations. Clear? If you are not getting any idea, I will recollect something that you have studied in the 9th standard. Okay, in 9th standard you have a chapter, gravitation, right? There you are studying a statement. Earth attracts every object towards its center. Earth attracts every object towards its center. Clear? So there is a force. That force can cause an acceleration, right? That force can cause an acceleration. That acceleration we termed as acceleration due to gravity. That acceleration we termed as acceleration due to gravity. Clear or not? Is it clear? Okay. So then we have discussed more that acceleration due to gravity remains same in the surface of Earth. Equator we have one fixed value, pole we have another fixed value, but that value remains constant at the surface of Earth, right? So now you got idea. G remains, that acceleration due to gravity, G remains constant, so we can use this equation in a particular kind of motion, right? Still we haven't introduced the topic. Now we got G is constant, G is acceleration due to gravity, right? So our application is something like that, right? Now I am giving an example. I have this pen or a ball, a stone in my hand, right? I am throwing this from the ground with a velocity u, right? This velocity will go up, go up, go up, go up. While going up, its velocity is decreasing, right? We can observe that. It's decreasing, 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 and it is reaching a maximum point. From there, it is not going up. It will come down, right? So first speed is decreasing, then speed increasing while coming down. Now you see that what is the definition of acceleration? Acceleration 9.8 meter per second square. This I can write 9.8 meter per second by second, right? What does it mean? In 1 second, velocity is changing by 9.8 meter per second. In 1 second, velocity is changing by 9.8 meter per second. Now you imagine the case. When you are throwing up, its speed is decreasing, right? Because Earth is pulling towards its center. right? So earth is providing acceleration downward, but it is going upside, so its speed will decrease, right? Motion is in one direction, acceleration is in opposite direction. So there we studied it is a case of deceleration, right? So in 1 second speed is decreasing, then final a point, then their speed is remain zero, then it start to come down. Is that case is clear? If you draw this like this is a ground. You are throwing a ball or something here. It's going up, straight, should be straight, okay? Then the maximum point, here your velocity be going to be zero, so because from the down speed is decreasing, then coming down again with increasing, right? Now my question, I have projected this ball, I gave some velocity. After that, who controlled this motion? Did I have any influence after throwing this object? No, right? That motion is fully controlled by earth or acceleration due to gravity, right? Do you have any doubt on that? I don't have any influence. I'm just throwing, I'm releasing from my hand. After that, it is guided by earth, right? So that motion is fully guided by earth. So this motion is called motion which is guided by earth, that we are calling motion under gravity. So our today's topic, motion under gravity, which means the motion which is guided by influence of earth. I got interest? Okay. Clear or not? Our daily example is this. Our daily life we are experiencing, right? You are throwing up, or from top you are something dropping to down. In cricket we are throwing, right? So many examples are there. This is an application. Then now today we are discussing how the equations we have to apply here. Okay, so before starting that, for board exam as well as entrance exam, just one question will be there from this part. That can be different case. In this motion under gravity, we will split into 3 cases. Okay, for every case, we need some prerequisites, means some basic idea. Okay, some basic idea we should require here. That basic idea, you know, the motion is a relative quantity, right? Motion is depending on frame. So here also motion under gravity. So I need a frame. Okay. To all the case, many books you can see different approach, but I am approaching whatever be the case, take your surface, earth surface as reference. This will be your reference point. Whatever quantity which is away from the earth or in the upward direction, you can consider as positive. Whatever quantity which is directed towards the earth, you have to consider as negative. 3 points. First one, take your reference as your surface of earth. Second one, whatever quantity is projected or away from the earth in the upward direction, that you can consider as positive. Then whatever the quantity which is downward or towards the earth, you have to consider as negative. Okay. Now you tell, we studied that A will replace as G, right? G, which direction G will act? Always. Okay, which direction G will act? G always acting towards the earth, right? So G will always be towards the earth. So G will be minus G all the case. G will be minus G all the case. Clear? From here, I am splitting this motion under gravity into 3 cases. In that, case 1, that is a ball projected from ground vertically upward. Vertically upward. Then we want to find what is the time of flight, time of ascent, I will explain everything, time of descent, and maximum height Hmax. Don't worry, we will discuss everything in detail. Okay, so first case, first one, what is the time of flight? You just consider this motion. This is my earth surface. A boy is standing here. Okay, this is our boy. He is having a ball in his hand. He is projecting the ball with initial velocity u. The boy is projecting the ball with initial velocity u. What you can observe? Okay, the ball will moving upward. So here you are reaching a final point, right? After that, the ball will not go up, right? So at this moment, you can say your final velocity is going to be 0 at the particular point. Clear or not? Okay, just listen. I am throwing this ball. Speed is decreasing, and reaching a maximum point. After that, this direction is changing, right? So first it was going like this, then suddenly direction is going reversed. Means at that moment, its velocity is going to be 0. Clear? After that, it will come down. It will come straight path. If I draw this, you will get confused. So I am just changing. It will come down. So finally, it will reach the ground. So when it is reaching here, it is having same velocity as u. We will prove that later. Time being, just keep like that. Just keep in memory. We are throwing with velocity u. Finally, coming back to the earth. At that time also, it is having same velocity. Just I will prove that. Our first case, time of flight. Time of flight. What is time of flight? Now you just get the word from time of flight, from the word meaning flight. Where is flying? In air, right? So time of flight means how much time the ball remains in the air. Means I am throwing, after that it is coming back to the same position. What is the time the ball took to come back to again to ground? Clear? Means the time which remains in the air, that is called time of flight. Clear or no? Is it clear? Then just understand the motion. It is going from here. It is going up, reaching here. Then direction changing, change. Finally, it is reaching the ground again, right? Or again coming to the hand of the boy. What is the displacement of the object here? Displacement. I am not asking the distance. Okay, I am asking the displacement. What is the displacement here? Displacement S is equal to 0. Then I am taking total time he took is capital T. Then you know the second equation of, right? S is equal to ut plus half at square. That equation, when it is coming to motion under gravity, that S is equal to ut plus half. A will replace I can as minus G, because G always acting towards the earth. Whatever quantity is acting towards the earth, you have to consider as negative, right? Then T square. In this particular case, I am considering S is going to be 0, right? U initial velocity is there. T is total time of flight minus half G T square. Here, this U will successfully go to 0 because of displacement is 0, right? Displacement is 0. then the 0 is equal to ut minus half gt square. Then just rearranging the equation. Minus ut is equal to minus half gt square. 1 t will cancel. So you are getting t is equal to 2u by g. Total time of flight, that means the object which is again coming back to the hand of the thrower, the object, the boy, that is called total time of flight. Is it clear? Is it clear up to here? Do you have any doubt how the displacement is to be 0? No, right? Okay, good. Now, this is a total time of flight. My second is time of ascent. What is time of ascent? Ascent means going up. Means the object is thrown from here, it went up, it is reaching the maximum height where v final velocity is to be 0. Then it will come back, right? Then here time of ascent means what is the time he took to go up, that is time of ascent. What is the time he took to come down, that is time of descent. Okay. So our next target to find time of ascent. I am using the first equation, v is equal to u plus at. Now we will tell what will be my v in this case. Anyone can tell. Anyone have option, anyone can tell. What will be my option v? Anyone? The v successfully will go to 0 because at final point the object remains rest for a moment. Otherwise you just imagine you are riding a car. The car is going up. Then you are putting reverse gear. It is going front. It will stop. Then only it will put reverse, right? At that moment, there is a momentarily it will become 0 velocity or 0 rest. So v will be 0. So at maximum height, don't forget this line. At maximum height, your final velocity v is going to be 0. Don't forget this equation. Never forget this equation. Okay. Don't forget this line. At maximum height, your final velocity is going to be 0. Now I am rearranging this equation. V is equal to u. It will be minus g time of ascent. At that case, this v will go to 0, then the remaining minus u is equal to minus g time of ascent. Minus I can cancel. So time of ascent is u by g. Right? Time of ascent is u by g. Then you will get a wonderful result. Now you just consider the motion, time of ascent, then time of descent. I am writing time of ascent plus time of descent will be equal to total time of flight, right? Time of flight. My handwriting has become lagging. Okay. So time of ascent plus time of descent is total time of flight. Now we got time of ascent is u by g. Plus time of descent you don't know, which is equal to total time of flight, that is 2u by g. Then what will be time of descent? U by g, right? Yes. Just solve this equation or take to the right side or just common sense, you will get time of descent is u by g. Then you are getting an important and a magnificent, a beautiful, a pyramid result. Time of ascent is equal to time of descent, which is equal to u by g. Is it clear up to here? Is it clear up to here, everyone? Everyone, sub. Which is it clear? Time of ascent is equal to time of descent is equal to u by g. Clear? Total time of flight is 2u by g. Clear? Then come to the third case. Maximum height, h max, or maximum height. Again you consider the motion. Okay. Again you consider the motion. From here you are throwing, it is reaching the maximum height. So this height is a maximum height, right? Here your velocity is going to be 0. After that it is not rising up, it is coming down. So at maximum height point, your velocity is going to be 0. Now use our kinematic equation, the equation which connects velocity and displacement. What is that equation? Yes, our third equation, v square is equal to u square plus 2as. This is the equation connecting displacement and your velocity terms. Right? So if I am writing in the terms of gravitational motion, v square is equal to u square minus 2gs. At maximum height, how I will change this equation? Anyone? Anyone in this classroom? Anyone? This v square is going to be 0, u square is there, minus 2g h max. Minus 2g h max. Clear aana makkale? Then arranging this equation, you are getting minus u. I am writing all the equations because you are not able to understand, right? 2g h max. This minus you can cancel. Then you will get h max is equal to u square by 2g. H max is u square by 2g. H max is u square by 2g. H max is u square by 2g. Clear? Is it clear up to here? Okay, now our three parameters is getting over, right? Time of height, time of descent, time of up. Clear? Then I will prove one more thing, right? That you can prove in two ways. One, logically we can think, or you can use conservation of energy to prove that, right? Or if I want, we can do the both ways, or we will do one method. That will be enough. What is the next one? I will find what is the velocity when it reaches the ground again. After hitting it will be 0, but just before the hit, or when it is reaching the hand of that throwing boy, what is the velocity? That is the case. I am taking, okay, you are considering the motion from here. From here, u velocity is going. It is coming up, up, up. It is reaching the maximum height where your velocity is going to be 0. Then again, the ball is coming down. Here you have a velocity. That velocity you don't know, you are taking v dash. Right? Now I am considering the downward motion only. Consider downward motion only. You can use this equation. You can prove this by using energy conservation also. But now we can apply the result which we got. Okay. Your velocity is v dash. Consider the downward motion. What is your initial velocity? In downward motion, your initial velocity u is be 0. Do you have any, are you agreeing with this? Are you agreeing with this? In downward motion, your initial velocity is 0 because I am considering only this motion, not up motion. I am considering down motion. Velocity was 0. From 0, velocity is starting. Right? Right? Okay. Then your acceleration will be minus g, no doubts. Your acceleration will be minus g, no doubts. I can use this equation, right? V is equal to u plus at. What is the direction of v? Okay, v I don't know. V u 0. A and minus g into time of descent. Time of descent. V dash and also V dash. So V dash is equal to para. Now you tell what is V dash minus G into what is time of descent? We got that equation, right? Here you have. What is that? Sorry. What do you have? Minus G into U by G, right? U by G. Time of ascent, U by G. Time of descent, U by G. Total time, 2U by G. This G will cancel. That you are getting V dash is equal to minus U. What it means? What was V dash? V dash was velocity at this point, right, where you have thrown this level. You are getting V dash is minus V, means magnitude wise these velocities are equal but direction is opposite, right? You are throwing ball upward, then your ball is coming downward, right? So your magnitude is same but direction is opposite. You can say speed is constant but instantaneous velocity or instantaneous speed remains constant, but direction is opposite. Clear? V dash is minus. Same thing you can get by energy conservation also, but to understanding this is enough for you. Okay, so next we will move with the second case. The second case, you are throwing the ball, you are dropping a ball from a height. Okay, you are dropping the ball from a height.